Cephalopod evolution is like by far my absolute favorite subject to talk about. And we are so incredibly lucky that squid scientist Dana Staff made this beautiful, beautiful diagram to talk all about it. So up here, we have the cephalopods that we have today. Squid, cuttlefish, nautilus, bobtails, the ones that you've seen and are pretty adorable. But what you may not know is how we got to those forms today. And those are our beautiful, beautiful shelled cephalopods. Now these guys right here, you probably do know about the ammonoids or ammonites. That's because those dudes were prolific. Like almost anytime you see a fossil on TikTok where they unearth a fossil, it's an ammonite fossil because they were literally fucking everywhere. But what you may not know is that ammonites are completely separate from our nautiluses. Nautiloids. Like the two are not the same thing. And where the ammonites completely died off, the nautiluses survived. And why we think they survived and the ammonites did not is because the nautiluses had the ability to go deeper and deeper into the ocean and to survive the extinction level events that the ammonites in shallow water could not survive. But what happened with coiloids is these shells that used to be on the outside had like a gene mutation happen, something funky happen, and you got a mutation that allowed their skin to merge over the outside of the shell. So now the shell is internal, all because a little freaking skin went wonky and decided to grow over it. And then over time, that shell slowly reduced. And so cuttlefish have the most of this external shell remaining in the form of a cuttle bone, which is actually how they maintain their buoyancy in the seawater, is because all of this cuttle bone is riddled with little pores that allow them to remain afloat. Now flamboyant cuttlefishes, on the other hand, their cuttle bone is dense, which is why they walk around on two little legs, or their little papillae, because they do not have the ability to remain buoyant. In squid, this external shell is now within the squid pen, which looks a little bit like this, and is that plastic bone everybody wants to get mad at me about. And in octopuses, they do actually have some remnants of that external shell. They're known as stylates. You can actually age an octopus using them. But these structures are super flexible and very thin, so they don't actually impede the octopus from being squishy. And deep sea octopuses have a little bit more of it. But yeah, isn't this absolutely bonkers?